All right, welcome back, everyone. We have 8.4 Heron's formula. I have raised the gain, so hopefully your ears aren't hurting. All right. Now, our learning goal is going to be to use Heron's formula to find the area of a triangle. Now, you may be going, I know how to find the area of a triangle, Mr. Farah. Why do I need to use Heron's formula? Well, this is going to address a specific situation where you won't be able to do it with a traditional formula. Okay. Now, Heron's formula is a method to find the area of a triangle when all the sides are known. Notice how nothing is said about the angle. With a right triangle, or a triangle where you have the height, you're easily able to find the perimeter. What I mean by that is we go, this is a triangle, and we say 1/2 times base times height. This height is, a value. And you go that way. Well, what happens when you have a triangle that's just like this, and you don't know any of the angles, but you want to know the area? Okay, in order to do that, we use Heron's formula, which looks like this. Area is equal to the square root of a semi-perimeter, which means half the perimeter, which we're going to cover in a second. So the semi-perimeter multiplied by the semi-perimeter minus the A side, multiplied by the semi-perimeter minus the B side, multiplied by the semi-perimeter minus the C side. Okay? Now the formula for the semi-perimeter is here, a plus b plus c divided by 2. Now if you're looking at this and you're like, that's ridiculous, okay? It's really not that bad when you break it down. You've done more difficult things. It's just kind of plugging in a couple numbers and evaluating, okay? So let me just draw a triangle for reference here. Okay, so we have a triangle here. We were given A, we were given B, we were given C. We would take these three values, go here, and get the semi-perimeter value. Once we have that, we can plug it in 4 different times, and then take these 3 values and plug them in and evaluate. Okay? So it's going to be a short video, all right? Now, our first one is going to look like this. Just a triangle, oddly shaped. We don't know the angles. And we're going to give a side of 3, 6, and 7. It does not matter which one you call A, B, and C, but I'm just going to call this one A, this one B, and this one C. Now to use Heron's formula to find that area, I need to do the semi-perimeter. So S is equal to A plus B plus C divided by 2. That's why it's called the semi-perimeter or the half perimeter, because you're just taking the perimeter, taking the perimeter here and dividing it by 2. So that is 3 plus 6 plus 7. 3 plus 6 is 9. 9 plus 7 is 16. Divided by 2 is 8. So that's what S is equal to. Now we take that and we go to the formula. A is equal to the square root, or A for area, right? S times S minus A times S minus B times S minus C. Okay? And we plug in all those values. So it's going to be equal to 8 times 8 minus 3 times 8 minus 6 times 8 minus 7. Okay, let's simplify. That becomes the square root of 8 times 5 times 2 times 1. Well, 8 times 5 is 40. 40 times 2 is 80. 80 times 1 is just 80 again. And we are taking the square root of 80. You do need to simplify that, okay? Now, if you've forgotten, you can make that factor tree. You look for 2 factors that multiply to be it, preferably choosing one that can easily be taken the square root of. So I'm going to choose 16 times 5 because 5 is a prime and 16 is a nice square. So the square root of 16 is 4. 5 stays inside, and so my answer is 4 times the square root of 5. Okay, and that would be your answer. And that's Heron's formula. Okay, it solves a specific issue. We don't know what the height of that triangle was. It's just a triangle, but we knew all the sides, so we can use this to still find the area. Okay, now it says I do, but this is a U. So let me give you a triangle. I want you to use this triangle with 7, 10, and 15, and then we're done. So pause it and give it a try. Okay, so hopefully you got it. You do the semi-perimeter. So S is equal to 3 plus 6 plus 7. Oh, I'm sorry. I'm literally doing the previous row. Oops. S is equal to 7 plus 10 plus 15 divided by 2. 7 plus 10 is 17. 17 times, or plus 15 is 32. 32 divided by 2 is 16. Okay. So again, this top sum to 32. 32 divided by 2 is 16. Okay, so S is equal to 16. Now I actually use Heron's formula, and I'm going to go right off the bat and plug in my values. So I get 16 times 16 minus 7 times 16 minus 10 times 16 minus 5, or 15. Okay. Then I keep going. Simplify. I get 16 times 9 times 6 times 1. Okay. 16 times 9. Oh man, it's been a minute since I've done that kind of work. What, 5,444? Okay. So that's 144. I did that really quick because 6 times 9 is 54. 10 times 9 is 90. 54 plus 90 is 144. And then I have 6 times... Oh man, I gotta do that with my head. You know what? Let's just kick this one old school. Let's do it. 6 times 4, 24. 6 times 4 again is 24, but we carry that. Carries 2. 6 times 1 is 6. Plus 2 is 8. Also, I made that laugh while I was recording one time, and my wife heard, and now she makes fun of me all the time. Yay. And this is going to be equal to the square root of 864. Obviously, we have to simplify. Now, in the previous one, I did it by hand, but with something like 864, let's just go ahead and use our tools, okay? And by our tools, I mean a calculator. And by our calculator, I mean that I'm stalling to get my calculator loaded right now so that I could use that. And by stalling, I mean it's taking forever. And there's our calculator. Okay. So we're just going to go right ahead. We're going to find our square root here of 864. Okay. Now, it gives us 12 times the square root of 6. This is that type of calculator that actually can do the simplifying. But generally, if your calculator is probably going to give you an actual decimal value. And in that case, just do, put the decimal value rounded to the tens or hundredths or whatever the assignment tells you to round it to. Okay. So guess what? That's Heron's formula. Okay. And there's not really a good math talk for this one. I don't feel like I've had a really valuable math talk in maybe about a unit. But it solves a specific type of triangle. If you really think about triangles in the wild, in real life, they're not perfect. They're oddly shaped. We don't always know the heights in certain ways. Okay. So hopefully you enjoyed it, and I'll see you guys next time.